Ready, Jamie? Yeah. OK. When we're looking at this problem, ladies and gentlemen, again, when we're looking at doing this by elimination, now obviously, if you guys remember substitution, I see that my variable is isolated, right? Remember we talked about when you have a variable with a coefficient of 1 or -1, look for using substitution? If I was going to solve this using any method, that's what you'd look at. However, we're focusing on using elimination for this method. So if I'm going to be using elimination, I remember I'm going to be either adding or subtracting the two equations. All right? But before I add and subtract, I have to make sure that I have coefficients that are exactly the same. And you can see that my coefficients for x are not the same, nor are my coefficients for my y. So what I need to do then is multiply by a multiplier to make them the same. And you could see that since 2 and 3, they have a common denominator of 6, or a common multiple of 6. But I would have to multiply both of them to get to 6. Whereas 1 and -4, or forget about the negative, just 1 and 4 have a common multiple of 4. So all I simply need to do to have them be the same is to just multiply my top equation by 4. So when you multiply your top equation by 4, you're going to multiply everything by 4. And what you obtain is 4x plus 2y, 4x plus 8y equals 8. And then my bottom equation is going to remain the same. Does everybody see, though, I have all I did was I determined that I wanted my coefficient of my x variables to be the same. So I multiplied them by a multiplier. And now I obtain two equations where my variable, Tiffany, x, has the same coefficient of 4 and -4. Now, since one's positive and one's negative, yes, Tyler?
On the bottom equation, can we just divide both sides by -4 and then put
Yeah. Instead of multiplying by 4, you definitely could have divided by 4. Yeah, absolutely. The reason why I didn't do the division, though, is because I didn't really want to deal with fractions. That would have been 3/4, and that would have been 25/4, so it wouldn't divide it. But yeah, you don't have to multiply. You also could multiply by fractions, which would be the same as like dividing. Absolutely. And you still would get the same answer. So now, since I have a positive and I have a negative, am I going to want to add or subtract my two equations? Add my two equations. So now, and which is nice if, just a little FYI, if you guys were, let's just pretend this was negative, or that was positive, I'm sorry. I don't really like doing subtracting, so what I would have done is I would have multiplied everything by -4 to make one of the I always like having one of the coefficients being negative so I can add. So if they're both going to be positive, then maybe make your multiplier negative, so when you multiply it through, it'll be negative. But that's just a little tip that I like to go through. So now let's just go and add them. 4x minus 4x is 0x. Cross out. 8y plus 3y is 11y. 8 plus 25 equals 33. Divide by 11. Divide by 11. Y equals 3. Now that I know that the value of y, again, to find the value of x, I'll just plug it into any equation. I'll plug it into the top equation. Again, x equals 3, so I'll just put it in parentheses. And now I can just go ahead and solve. Y equals 3. Thank you. Not x. So x plus 6 equals 2. Subtract 6, subtract 6. X equals -4. Oh, sorry.